I am going to start with number 2. Okay. So before as you know very well, this is the traditional procedure. As a being as a student of electrical engineering of the secondary technology, you must know the power system operation and control syllabus as well as is the departmental and institute vision of it, right? So this is your vision of the institute and this is your the mission of the institute. Similarly, vision of the department, mission of the department, then course objectives. Okay. So the course outcome, that's the course outcome of PSOC. And now this is the main important reactive power control. So first unit is your load frequency control. So then second unit is reactive power control. So these are the content which content you are going to learn. So then the basics of reactive power control. It is a very easy unit as compared to unit 1, right? So the basics of reactive power control, then excitation system of generator, then the static and dynamic voltage stability, and the methods of voltage control. So then modeling of excitation system also you have to study. Then methods of voltage control, these are the various methods. So these are the 6 methods are there, but in your syllabus only the 2 methods are included. That is one is the tap chimney transformer and second is the voltage control of generators. So then next the system level voltage control, then tap setting of OLT transformer and the UVR injection of the switch capacitor to maintain acceptable voltage profile and to minimize the transmission loss. Okay. So now I am going to start this unit. So basis of reactive power control, it is a very important question, and that question asked in the any type of exam, term based or your 8th semester exam. This is the important question. It is important topic. Okay. So based on this, the definition of the basics of the reactive power. Being an electrical engineer student, you must know the basics. Which type of powers are there? Right? Active power, apparent power, and reactive power. So we in this unit we are going to control the reactive power. We are going to control the reactive power. So the definition is basically the reactive power is calculated as in a single phase system as well as in a 3-phase system. Is it possible to calculate or to determine the reactive power in DC circuit? No. Only it is possible in your DC circuit only the real power or active power that is measured in watt. But the specialty of the AC circuit is you can calculate or determine the real power as well as the apparent power and reactive power. Okay. So real power measured watt, then volt ampere VA, and reactive power VAR, reactive volt ampere. Right? So these are the various control strategies, various control devices are using to control the reactive power in a power system. So first of all we are going to understand the basic concept of reactive power control. So definition is the reactive power is a power that oscillates between source and load. Between source and load. It is an oscillation. That is of the imaginary. The imaginary power. The oscillation will be there. Why oscillation is there? Because already mathematically you can express the reactive power in the single phase system as well as 3-phase system. What is the formula? That the VA sin pi, right? In single phase and in 3-phase root 3 VLI sin pi. So sine function here when you taking the sine function of the power factor angle. This is the sinusoidal function, and sinusoidal means it is the alternating one. It is a alternating one. That alternating waveform, it is the sinusoidal waveform. It is the alternating. That is creates the oscillations. That's why this reactive power is also defined in another way. It is oscillates between the source and between the source and load. Right? So in AC system, and is required to maintain electric and magnetic fields in inductive and capacitive elements. Okay, so in a electrical engineering, active devices and passive devices already you know very well. Okay, so then in that active devices in the energy electrical storage elements, right? So resistor, is it energy storage element? No, it is a heat dissipating device. Energy totally placed in a resistor, but the inductor and the capacitor, these are the two elements, are store the energy. Store the energy, right? That is half Li square and half Cv square. Half Li square and half Cv square. So inductor and you have the